Good morning, everyone. Before introduce the speaker, I would like to say about Azadi ka Amrit Mahotsav. Pre-speaker among participants. जैसा कि आप जानते हैं, आज़ादी का अमृत महोत्सव एक प्रगतिशील स्वतंत्र भारत के 75 गौरवशाली वर्ष को मनाने के लिए एक सतत उत्सव है। भारत सरकार की इस पहल का उद्देश्य हमारे स्वतंत्रता संग्राम और एक राष्ट्र One minute, please. सॉरी भारत सरकार की इस पहल का उद्देश्य हमारे स्वतंत्रता संग्राम और एक राष्ट्र के रूप में हमने जो मील के पत्थर हासिल किए हैं उन पर ध्यान केंद्रित करना। आज़ादी का अमृत महोत्सव भारत के लोगों को समर्पित है, जिन्होंने देश के विकास और इसकी विकास यात्रा में महत्वपूर्ण भूमिका निभाई है। आज़ादी का अमृत महोत्सव के तत्वावधान में नागरिकों को अपने घरों में भारत का राष्ट्रीय ध्वज फहराने के लिए प्रोत्साहित करने के लिए एक अभियान हर घर तिरंगा शुरू किया गया है। अभियान के पीछे का विचार लोगों के दिलों में देशभक्ति की भावना पैदा करना और राष्ट्र निर्माण के लिए अथक परिश्रम करने वालों के योगदान को याद करना है। स्किल काउंसिल फॉर ग्रीन जॉब 13 अगस्त से 15 अगस्त 2022 की अवधि के दौरान अपने कार्यस्थल एवं घर पर राष्ट्रीय ध्वज फहराने और हर घर तिरंगा अभियान को एक शानदार सफलता बनाने के लिए आपके समर्थन का अनुरोध करते हैं। जय हिंद, धन्यवाद। I'll welcome to the 35th series of webinar. Today we have a very learned speaker who will be sharing his expertise and experience on creating wealth from waste, opportunity and challenges. Brief introduction or Dr. Ratnesh Tiwari is an engineering postgraduate and has a doctoral degree from Indian Institute of Technology, IIT Delhi. He has more than 8 years of extensive experience as a researcher and consultant in the sustainability space. He has worked on several sustainable development programs sponsored by different national and international agencies like Ministry of Renewable Energy, Ministry of Human Resource Development, the Energy and Resources Institute, Container Corporation of India Limited, GIZ Germany, World Bank, and United Nations Foundation, USA. Dr. Tiwari is the co-founder and CEO at Koshish Sustainable Solution Private Limited. Koshish focused on promotion sustainable energy solutions, sustainable agriculture practices, and sustainable eco-friendly products, leading to sustainable economic growth with environmental upgradation leading to irreversible human development. He is passionate about socio-economic development of villages. He has a excellent interpersonal and leadership skills. Dr. Tiwari has always focused on making a difference and creating positive change in the life of others. He believes that it is significant for all of us to create a cycle that induces abundance in the community. A firm follower of popular sayings, it is not what we get, but who we become and what we contribute that gives meaning to our lives. Dr. Ratnesh has made this noble approach and indispensable part of his life. Thank you. Now I request Dr. Tiwari to start the presentation. Over to you, sir.
Thank you, sir. Thank you, Singh, sir. Thank you. Thank you for this opportunity. I would like to congratulate SCCJ team uh, for this great initiative. Uh, I would directly start with my topic, which I am going to talk today. So, yes. So, creating wealth from waste, opportunity and challenges. At the moment, globally, this is a very burning issue of how to manage the waste. Generating the waste is a easy task, but how we can minimize this waste, how we can reuse, how we can recycle, that is the major concern which is going to be talked in this lecture. So about firstly I will talk about the flow of the session. I will firstly introduce about my organization, that is Koshish. Then I will talk about the waste to wealth, talking about the biogas technology and biomethanation, as we are working on the organic waste at the moment. Then different types of different technologies of biogas system. Uh, After that, we will talk about the market analysis and opportunity and challenges that is going to be involved in the sector. So, Courses is an initiative from IT Delhi alumni, myself also from IT Delhi itself. Our focus is basically on the future generation, how future generation can survive better. So, working on the sustainable development by transforming projects impact into benefits for our clients, but also for surrounding communities and environment in which we work. So we are working on three verticals: sustainable energy, sustainable agriculture, and sustainable sanitations. So today I will talk about the sustainable energy solution, which is biomethanation process, the biogas technology on which we are working. So yes. So as I said earlier, the waste material to be reused, recycled, and reduced. So which either organic waste or inorganic waste, that the need of the hour is to reuse, recycle, and reduce. So we are not working on inorganic part, but yes, we are working on the organic, which is very much very good material for the energy production. Energy can be in the form of heating, power, or CNG. So next. So as we are talking about the biogas technology, since we are talking about how to recycle this biodegradable waste. Biodegradable waste like cow dung, poultry litter, then any type of these manures and other food waste, fresh mud, any organic material that can be converted, that can be converted into biogas. That biogas is mixture of many gases. The main gas in biogas is methane. Methane, which is useful for us for heating, power, and CNG generation. So biogas, as we see, biogas production refers to degradation of biodegradable waste in the absence of oxygen. This is anaerobic digestion process. The total biogas production, if we talk about them at the moment, in India is around 2.07 million meter cube per year, which, however, our potential is much more what we are producing at the moment. So, biogas is, as I said, the mixture of many gases: methane 55 to 60%, carbon dioxide 35 to 40%, and other H2S and water vapors are also there. So, as we compare with this fuel, biogas as a clean fuel, you compare with the other fuels like LPG, CNG, and firewood. The calorific value of biogas, if we see here, the raw biogas, we are talking about the raw biogas, that is 20 megajoule, and LPG, CNG, that is 46 to 50 megajoule. But yes, after purification, when we extract CH4, the main gas of from biogas, then that is after purification getting compressed and then fill in the cylinders. The same biogas which we are getting, if we extract methane, that will have the almost same calorific value what we are getting from LPG and CNG. So this is very useful gas for our energy needs. And also this is very clean, as this is renewable energy, and it's produced from the waste itself, which is waste, and we are creating wealth from waste. Yes. So basic process of anaerobic digestion, if we talk, there are 4 reactions which are taking place: hydrolysis, acidogenesis, acetogenesis, and methanogenesis. So it has, since organic matter has a very complex structure, so the microbes takes part, they plays its role in decomposition, in fermentation of this organic waste, and lastly the methane, CO2, H2S, and water vapors with some other small amount of gases are produced. So if we, as I have discussed, these mainly 4 reactions are taking place inside the digester. After that, the biogas is getting produced. Next. If we talk about the overall process, there is overall technology. We have the waste collection platform, waste is getting collected, then the pre-treated. If there is requirement, there is some agri residues which are getting pre-treated before going to the digester. Then it is mixed with water to get it the mix enters in homogenizers to break down large particles into smaller ones, especially of the food waste and other waste which are of a bigger size. Then this is fed into the digester, which anaerobic digestion takes place. And after that, the gas is biogas is getting collected in the gas holder, and biogas is collected in the gas holder, and the slurry gets out from the outlet tank, from the outlet pipe to the outlet tank. So this is actually, we can see that waste is getting into the waste collection platform, then it into the inlet tank where it is getting homogenized for this with the water as right ratio of solid content is required for the biomethanation process. Then the waste is going to digester from the inlet, and the gas after a time, HRT of different waste is depends on the waste material actually. So waste, then gas is getting generated from and collected in the gas holder, and this fertilizer as slurry is getting out from the outlet pipe to the outlet tank. After the slurry is getting slurry, that is a mixture of solid and liquid, and we have mixed liquid with that material, the organic material. So that can be further used as organic manure. That can also be used in the form of green coal by briquetting or making a pellet of these material. So yes, sir. Yes, thanks. So overall, when biogas is getting produced, so we can use for heating purpose. We can use directly the the raw biogas after eliminating this H2S and CO2 from H2S and moisture. CO2 removal is extensive process. CO2 so bio upgradation of biogas is required. Purification of biogas is required by removing these impurities. Our main content is CH4, the methane. So removing CO2, H2S and moisture is required for the vehicular application, for the commercial application. If we are going to use it for as a transport fuel, then it need to be purified, compressed and bottled in the cylinders before using in the vehicles. So here next. There are many factors which affect the biogas production process, like CN ratio, carbon and nitrogen ratio, optimum 20:1 to 30:1. And the dilution, as I was talking about, the mixing water with the organic material. So that is to maintain a proper TS inside the digester, that is 7 to 10%. The TS value around 7 is required. The temperature in the mesophilic range 29 to 40, that is very much optimum for this condition. And HRT, at what time HRT is exactly the time span the organic material survives in the digester before hitting it, before it gets fully composted. So it also depends on the type of organic material. So yes, these are the factors which are required, which need to be optimized before before designing the biogas technology, biogas system. It all depends on the type of waste and temperature, the environmental conditions, and all these things. Yes. So different type of waste organic waste are available, and they have their own production capacity for biogas. So as per cubic meter of biogas, so it's 1,000 liter of biogas is getting produced from 23 to 25 kg of cow dung. Earlier, we have in India major population knows biogas by gobar gas. So as we see here that gobar gas, the cow dung itself do not have that much of efficiency, but yes, this is very good material for which acts as inoculum, as microbes are there. So that is getting used in the plant. And other ways like poultry litter, food waste, press mud, Napier grass, they are highly efficient than cow dung for this biogas production. Also, the material, the property of this, the material also ensures the amount of methane is going to produce. Every waste material has different methane content value. So most like poultry litter produces more methane content in the biogas. So lot of biogas potential is there in the country. We are producing a lot of waste from MSW, then we have cattle. So there is a good opportunity to work on this renewable energy sector. Next. So biogas, raw biogas, when it is produced, it can be used in 3 different forms: for cooking, heating, bio-CNG, and power generation. So like Next. This is for process flow diagram for this cooking application as gas is getting produced and we are using S2S, S2, the moisture removal filter and some H2S removal filters that then we can directly use in the stoves like we are using LPG stove. The stoves for biogas use are different from the LPG stoves. So other things are common everywhere like outlet tank, then slurry pit. Next. Next is this is for power production. After H2O, you can see that after H2O and H2S removal, we are using that gas into the biogas gensets. There are highly efficient gensets available in the market, and we can directly produce electricity power from this genset even without removing CO2 from it. Since these plants are largely for the commercial purpose, they cannot be used at domestic level. That much of material is not available at domestic level. So we need slurry separator for removing this liquid and solid material from this produced slurry, and organic manure again can be used in the agriculture, and also can be used in other ways like green coal, the pelletization and briquetting. Yes. Next. Next is what government is talking more about this initiative producing bio-CNG. In fact, they are targeting to install around 5,000 plants in the country to produce this bio-CNG which can be used to replace this burden of petrol, diesel, and CNG. As these are non-renewables, and we are majorly dependent on the import from the other countries. So since abundant amount of waste is available, this can be a good initiative. Whoever want to go for new venture can definitely choose this bio-CNG industry, as these plants, I can say that these plants, the ROI period of these plants is around three years. But yes, the life of these plants is, we can consider it 15 to 20 years. So there is a big opportunity for the new entrepreneurs, new startups to come into this sector. And definitely this will not only achieve their goal of financial purpose, but also this will contribute towards the environment by reducing the CO2 and the CH4 emissions in the environment. So yes, in this bio-CNG, what we need to do, the produced biogas need to be purified. Purification of as we were earlier removing S2S and water vapor, but now we need to CO2 also, remove the CO2 also, because CO2 is also available in a big percentage in the raw biogas, around 30 to 40%. So that will be removed in biogas purification process. There are different technologies which are getting used for biogas purification. In India, majorly PSA, pressure swing adsorption, and water scrubbing. These two methods are getting used. Yes, globally, but there are other methods of purification are also used, like membrane separation and all. So after purification, the gas need to be compressed. The biogas compressors are required to compress the purified gas at 200 bar, around 200 bar. What our standard BIS standard is talking about. It should be compressed at 200 bar, and then it can be used for the vehicular application. Also, it can be replaced to the industries who are using LPG and CNG for their purposes. And presently, government is running a program, Satat scheme, which is ensuring if you are going to produce more than 2 tons of CNG, by CNG, then they will directly connect you with the oil companies. They will ensure that they will purchase the gas, whatever you are producing at your place. So this is a good initiative, and also at the moment, government has increased the cost. Earlier it was purchasing it 40 at rupees 46. Now they have revised it, added another 8 rupees to it. So yes, this is very much considerable and very much important for the country and as well as for the environment. Next. So if there are many advantages that we discussed, that this is eco-friendly, renewable, and also that the slurry what we are getting from this biogas plant is very useful. That can be used in the agriculture. As I have said earlier, that we are working on the energy, agriculture, and sanitation. So energy, we have connected agriculture with energy. Since we are producing fertilizers which are very rich with nutrients for the plants, so we are promoting that these gases, these manures to replace the chemical fertilizers. As the chemical fertilizers are getting used abundantly, and they are depleting the health of soil, and carbon content in our soil is depleting day by day. So we need to fix some organic content in the soil. So this is a good material which can be used for the agriculture production, and our dependence on chemical fertilizer can also be minimized. Also, for using this fertilizer will definitely cut down the input cost of the farmers, and definitely this will, since government is talking about doubling the farming income. So there are two ways. Either we should increase the production, increase the output, or we can decrease the input cost. So this can be used for reducing the input cost, and also a healthy food can be produced from our farm. So yes, this is very advantageous for the environment, and also for the country. Next. So what now I will talk about what we are doing actually. So we are working on different scales, right from domestic to commercial scales like bio-CNG plants. We have plants ranging from 2 cubic meter to 12,000 cubic meter, what we are working at the moment. So these commercial, residential, and industry, wherever there is availability of the organic waste, we can use that waste in generating energy, and that generated energy can be used either self-consumption, or that can be sent to the open market. So our products are like next. So we are very much focusing on the domestic unit. We have developed two prototypes, and also we are working on other prototypes. The major concern what we see on the ground, as earlier, there are many plants which were constructed on the ground, but they are not functional at the moment. The problem was that they were not built with technical know-how. Also there were problems. Mainly, there were problems of the leakage on the gas storage gas chamber. The fixed type of plants were used. So their life was also a concern. Skilled manpower was not available on the ground, which who can give the after sales services, to the clients. So we are working on the modules on which we can give more than 15 to 20 years of warranty of overall functioning of the plant on the ground. Since if what I see that if we really need to see impact, we need to capture the domestic market. We need to install these plants on the domestic for the domestic use. As for domestic, if we talk about the LPG, what they are using, if family is using a cylinder in a month, then ₹1,000 they are investing on that. But the biogas plant, if you are in the cattle and also they have food waste in their home, if they use a 2 cubic meter of biogas plant, so they can use that gas to replace that LPG for their cooking purpose. Also, the produce slurry can be used in their farms as an organic fertilizer. Next. So as you see that 2 cubic meter of biogas plant, which produces around 0.8 kg equivalent to LPG, that is very much, that is a family do not need more than this amount of LPG on per day basis if they have 4 to 5 family members. So what we see that we are saving around 3,450 rupees on on monthly basis if we are going to install a biogas plant in our home. So the cost of biogas plant is good quality of biogas plant on which we are ensuring more than 10-15 years of warranty. That is around 55,000-60,000 rupees. So the cost is we are able to recover the cost in just about 1.5 years, and warranty of the plant is more than 10 years. So this is very much useful on the domestic level as well. And we are working on our R&D team is working on 2 and 3 other units also, which are more compatible to use, which are more comfortable to use, like how we can better use the slurry, how we can better use the waste, how we can in the plant, also how we can increase the efficiency of the plant. So we are working in that direction also. Definitely will come up with 2-3 modules in next 1 year. Our 2 modules are already there. So yes. So next we are working on commercial units. What we put it name as Badlao model, biogas assisted rural development, land and agriculture reform by organic farming. So this we are focusing on the farming community, like some poultry farmer, dairy farmer, piggery farmers, who are producing a lot of waste at their farm, and also they have requirement of energy in the form of power and heating. So we are assisting them. We are talking to this community that if you are going to have a biogas plant at your farm, then you can be self-reliant on the power and energy need. Also, your waste will be better utilized, and then that can also be another income source for you at the farm. So this is one model what we are working on. These are some units what we have installed at different locations. Next. So Next is compressed biogas with Vyapar model. What we are talking about, the bio-CNG, the compressed biogas. So that is completely a revenue generation model for as taking it as a startup, as a business. So yes, we are working in that direction also, ranging from 1,000 cubic meter biogas plant, which produce around 400 to 500 kg of compressed biogas, to 12,000 cubic meter, which is producing around 5 ton of CNG on daily basis. So as I have discussed that we are working on PSA and water scrubbing, focusing on water scrubbing, that is more efficient. Water scrubbing technology is more efficient. Also, the purity of gas can be better ensured with this technology. So we are working in this direction. This biogas, the water scrubbing method is basically we capture the CO2 and the H2S with the flow of the water. So this technology we are using. Yes, next. This biogas bottling technology, biogas bottling for compressors and cylinders are getting used. Compressors for compressing the gas at 200 bar pressure, and then this is filled into the cylinders in the form of cascades. Yes. So also what we are taking a challenge on the ground, that if there is any plant which is not working, we take that challenge. We will start that plant. What I see, or what our team thinks, that if science says that this is possible, then that should be possible. Why should not that work? So if any plant, if any capacity is not working at the ground, then please let us know. We can definitely start that plant. We can restart. We can in fact optimize the efficiency. We can restart that. We can operate that plant in the full capacity. Yes. So that was the part of the biogas, and this is the slurry what is getting used. The slurry, the slurry produced from the plant is highly nutrient rich. And we can see that the slurry has higher NPK values than other manure what farmers are using for the organic material. So, this can be used in the farms. Also, value addition can be done by producing the chrome, phosphate-rich organic manures. Other value additions can also be done depending on the need of the farm, need of the plant, need of the soil. That can be done. So this is a big opportunity. This is really very useful for the farming community. Also, this can be used. This can be converted into the biomass pellets, briquettes to produce green coal. I'm talking about green coal because the pollution that is going to coming out from the raw organic content compared to this is very low. So this can be used. In fact, Ministry of Power has also advised to reduce consumption of coal in thermal plants by using 5 to 10% blend of biomass pellets. So this slurry which is getting out of this plant can also be converted into green coal, the biomass pellets, and that can be supplied to the power plants. That can be used in the power plant. They are they meet that criteria what they are actually looking for. Yes. So market, there is, as I talked earlier, that there is a lot of opportunity since our government is also trying to reduce the carbon emissions to go for net zero. So renewable energy sources are very much important, and and managing the waste is also plays an important role in production of this renewable energy. So yes, there is a lot of scope. There are a lot of drivers which are really making this sector very important, very useful. Yes, next. So as we see that 70% population is still, if we talk of more than 60% is still living in the rural areas, and they have cattle, they are producing a lot of organic waste. So that can be, so domestic sector itself has a big market. Also a community level plants can also be made on the panchayat level, on village level, which can directly produce, that can directly supply the required gas to the households through pipeline, and then manure can be used in the farms. So yes, a lot of cattle waste is available, MSW waste is available. So a lot of opportunity is there. Government is also working on Satati scheme to go for 5,000 plants by 2024. So with this, the advanced technology, and technology is very advanced at the moment. There is no problem at all in the technology end, I can assure that. But yes, continuous supply, maintaining a supply chain of waste material, that is where we need to work on to make it more successful on the ground. Yes. So challenges there are, yes, technical manpower, the skilled manpower on the ground is still a problem, because since the industry is growing day by day, we need more skilled manpower on the ground. We can definitely support the technology. We can support the after sales of the system. So this needs to be work on, and in fact, Skill Council is really working on taking job role, defining job roles, and also for biogas plant technicians also a job role can be formulated from the Skill Council itself. That will be really helpful on the ground to train the people who can provide the services, who can help in the construction of the plant. So this is very much required on the ground. Also a major concern of capital investment, since capital investments are high for these commercial plants like CNG. So special attention is required on the bank level. People are looking for funding, but yes, they are facing many challenges at the bank levels, and with that, definitely that this industry is facing an issue. And also, so as I said that waste is available in abundance, but yes, proper supply chain is also required, so that the plants can run on the efficient in the efficient way as per their technology and as per their manufacturing system. Yes. So this is what we are doing, and this is very much required for the community, for the environment, and for our initiative towards net zero. Sustainable development is development that meets the needs of the present without compromising the ability of future generation to meet their own needs. So we can work on our present generation also, and definitely saving the environment, saving the resources for the future generations also. Thank you. This is all from my side. Any questions, any answers, definitely I would like to.
Thank you, sir. Now I request Dr. Dhamija ma'am to ask some questions or
PV Singh, I have raised my hand also. I want to compliment Dr. Tiwari on the, the various initiatives which you have shown, that
Thank you,
Badlao
ma'am.
scheme and on the O&M. And of course, your coverage is very good. You, in a very simple way, you have presented the biogas technology. I think biogas technology cannot be presented in a comprehensive and a simple way, the way you have presented. But
Thanks a lot,
my
ma'am.
question to you is that you saying that wherever there are plants, the NCR study which had been conducted, they had said that 70% of the plants, the domestic plants or the small plants, they were functional. So I think the ministry they had a scheme for, the O&M repairing and all that. It was only run for 3 years. But can you not get the list of those plants which are not functioning? I have visited villages where there have been pits and no plants. I don't want to wait. And those villages are very good villages. It's not that development is not there. Because once a biogas plant gets stuck, then until and unless, it is the entire thing is taken up immediately, then it is very difficult to revive it.
Right.
If you remember, Dr. Ramaswamy was there from TNU. He had developed a small kit where you could see the pH and you could see whether it is because of the pH or it is because of the biological this thing. So so you can get in touch with the ministry or you can get in touch, and then under organic farm, that the portable plant which you have shown. The government of Karnataka also had a scheme of organic farming where they had taken up that 2 cubic meter. Was this successful? I think that was from Syntex. Are you aware about that?
Yes. The problem with the FRP material plants is that their lifespan is very, very small. Actually, the major problem on the ground with these plants is that they faces issue of leakage in the gas storage itself.
In the portable ones.
Yes, in the FRP material, with the FRP material. So that need to be taken care of. And in fact, what we are doing, and we are using we are using MS material, and then we are using FRP on both sides of the plant. So we are pasting FRP on MS material itself.
So this model is approved by MNRE. They have given approval for your this portable plant.
So I still actually we have developed just 2 months earlier. So we have not approached MNRE for it. Actually, there is not any subsidy on the plants. So for the subsidy, only
the scheme has been revived. It has been revived. I think till 2026, it has been revived. The subsidy scheme. Yes, it has been revived. I don't know the details. You can always check up with MNRE.
Sure, ma'am. Details are not on the public place at the moment.
Maybe
in fact,
there will issue.
In fact, there are many clients who are actually waiting for this scheme, the subsidy on the biogas plant.
Yeah, there was a lot of uproar. Even our Biogas Association took up. They wrote long letters. It was also in the newspapers. And the EFC has reconsidered the proposal, and it has been continued till 2026. So you can check up with the MNRE. I think Mr. Meena must be
that would be really good for this sector actually.
Yeah, that is
waiting on the ground.
He has already informed us. I think Mr. Meena, we can just ask him for more details. Can you give the rights to Mr. Meena? He's there with us. He attends all our sessions. I'm very impressed, Mr. Meena.
Rohit?
Yes, sir. I already get.
Mr. Meena, please, you can come on board and explain.
Namaste, madam.
Namaste, how are you?
I'm fine, madam. Our bioenergy schemes, right from small biogas to large biogas plant, have been considered recommended by the EFC on June 27th. And now we are revising the scheme guidelines.
Great news.
The guideline will be notified soon.
Great news for the sector. Thank you for all the efforts from the
The
ministry.
subsidy will continue. And what about you had once had a dialogue with me regarding the skilling? Is it still there as a part of the program, or is it now with Dr.
Yes,
Vasanta?
yes, madam. The major changes is that the bagasse cogeneration plant will not support. This
Okay.
component is stopped, and we introducing the new concept, new point like pelleting and briquetting component.
Okay, that's very good. That's very
Yes.
good in pelleting and briquetting, because we tried very hard, but we were not very successful.
Yeah, and we
That is-
increasing the subsidy also for small and medium-sized biogas plants.
So how much will it be from 8,000? Yeah.
Subject to approval, but yeah, we substantially increasing the subsidy.
Okay. That will be a big boost for the farmers,
Yes.
I feel.
Definitely.
And can you tell him something about the O&M, the repair scheme which we had earlier? Is it still continuing, or will it be a part of this?
Actually, under the scheme, there is a provision for 10-year successful, 5-year free or warranty-free O&M, and beyond 5 years, there is no scheme for repair, but yeah, it should be there.
News you have given, I was waiting. I had asked Dr. Vasanta, but she was yet to give the details. So,
But
really,
state
thank
can,
you for- yeah.
state can have a provision for repair or remedial action after 5 years for the biogas plants with their own efforts. So
That is very much needed, actually. In fact, there are many projects which are on hold, and they are waiting for the subsidy and the new policy from the government.
Yeah.
Yes.
Transfer to petroleum ministry, but the smaller plants also need attention.
Yes, ma'am.
So the
Major
farmers
impact
are-
is going to come from the domestic level itself.
Yeah.
Yes.
Yeah. So you will be in the implementation also once the scheme is on board, or you will be only like, I think you can do the implementation. You must be a large.
Yes. Yes, ma'am.
Right.
We are working in the direction of implementation. We are working. We are making the projects on the ground, taking the turnkey projects, also working as consultants. Yes, sir. So
So that was very nice. This is one area which has been neglected for long, and I was thinking it will die down if the scheme doesn't revive. So that is good. And you keep up
in
your
fact, when you were in MNRE, you were also focusing on this clean energy. And
Yeah.
yes, so this need to have attention.
Yeah. Some sort, maybe that's saying that the revised guidelines are there, so they can change with time, but it need not be scrapped off.
Yes.
Yeah.
Yes.
So
Yes.
once again, thank you very much. It was very nice.
Thanks a lot, ma'am. Thanks a lot.
Excuse me, ma'am.
Yeah.
Ma'am, excuse me. Sandeep Nain on the chart, he is written, Dr. Saab, what is your take on organic farming when we see Sri Lanka model getting failed?
So organic farming is good, but model of Sri Lanka is not good actually. So shifting the complete system into farming system into organic farming is what challenge faced by Sri Lanka. So this need to be exercised in a very good, very proportional manner. So we cannot shift everything. We cannot declare that you should shift your farm directly to the organic farming. Definitely the produce is going to be lower in the first 2 years. So it takes its time. So the organic farming for healthy food is important, is required, but model of Sri Lanka cannot be replicated.
Yeah, I think I agree with you. I had been to the spice farms in Goa. So they also had shifted, when they shifted to organic, imports. Initially 2 years, their, the production had gone down, and then they got better results.
Yes.
The Sikkim also as one of the states, which is a complete It is completely, green. It is declared as a green state, and they have organic farm.
Organic farming need patience actually.
Yes.
The farming community do not want to wait for 2 years, 3 years, 4 years.
Yes.
So yes, they can start working on a part of their plot. If they have 4-acre land, they can start on 1-acre land to start with. Then they can shift one by one to get fully organic.
Yeah, I think there's one more hand, Mr. Singh.
Yes.
Hi, Dr. Ratnesh.
Thank
First of all, thank you for this presentation. I have a very small question. In one of the slides, you have mentioned that for running a 2-3 meter cube biogas plant, we need around 50 kgs of cow dung, right? Which will generate energy or the gas equivalent to 0.8 kg of LPG, right? So if you are
Yes.
aware that, in government, in the state of Chhattisgarh, they have a scheme, Godhan scheme, right? Under this scheme, farmer can sell their cow dung at 2 rupees, per kg cost. So don't you think that if this model continues by the government of Chhattisgarh, then there will be a, problem arises of getting cow dung from the farmer? So, because farmer are more intent to, generate revenue by selling their cow dung instead of, using that cow dung into their biomass or biogas plant. So what your take on that?
Right. In fact, I visited Vilai and was in the room of ADM, who was showing that portal where he was saying that today this much of cow dung has been purchased at the rate of 2 rupees per kg. So purchasing 2 rupees per kg the cattle dung, government is taking an initiative, and all farmers can sell at 2 rupees per kg. Then definitely, if government is going to invest on that, to use that cattle dung to convert it into compost or energy, then it is definitely feasible. But 2 rupees cattle dung at the 2 rupees per kg, which government can purchase, I'm still in doubtful, and I've seen that on the ground itself, that purchasing 2 rupees per kg is never going to be a sustainable model for any government unless they are going to infuse money on that. So
what I understand from Punjab is government of Punjab, they were doing it at 50 paisa per kg. I think so.
50 paisa is okay. Up to 1 rupee, it's okay. Any plant can be made feasible up to 1 rupees kg. But with 2 rupees per kg and using that in the plant or for composting, that can never be feasible unless we are getting it exported at the rate of more than what in Indian market is available. That's someone was saying that in India we are not able to get even 5 rupees on biofertilizers, and we are able to sell it in Arabic countries at the rate of 50 rupees kg. So that is, if that is possible, then everything is feasible. But purchasing 2 rupees kg, 2 rupees per kg cow dung and using it, after the purchase, you need to convert it into usable form. That cow dung cannot be used in the raw form. What they are doing in Chhattisgarh, they are purchasing that and they are using it for the vermicompost, making the vermicompost, and then they are selling it to the farmers again, going back to the farmers. So farmers are not able to purchase that at the rate of more than 5 rupees per kg. So yes, government need to infuse money on that. If that is they are going to purchase for the population, for the peoples of the country, That is very good model if the government is going to purchase 2 rupees per kg.
No, but for the last large biogas plants, community biogas plants, which we had set up in Punjab, Gujarat, we had a barter system where they will give the
Yes.
cattle dung and they will get the gas in return. So that
Yes. Yes, ma'am.
I feel what you're saying is it may be for pharmaceutical. There's a scheme also which has come up. And in fact, somewhere the departments have also come up for promoting the cow and the products, maybe
Yes.
it is a partial this thing. But in domestic, nobody will go. If you have 2 or 3 cattle, I have seen all over the country, they have small 1 cubic, 2 cubic meter biogas plants, and they are very happy with it, and they're using it for their, utilization for cooking. So I feel maybe the dairy farms or the big this thing, they may sell it, but the small farmer who is using biogas or who is using all this in his home as a substitute to LPG. Women have really been very aggressive on this when I used to visit.
Yes.
Somewhere the temperature goes down in the month of January. They were saying why it is not working. We are so happy with it. And subsidy was needed because they can't afford to set up a biogas plant without some financial assistance.
Yes.
Yeah.
That is required. In fact, we have made a model at Tata Tea Estate in Assam, Hatikuli, where a plant that is of very small capacity of 30 cubic meter that is running on the cattle dung and the waste, the green waste. So cattle dung, there are many staff in the tea state who have cattle. They are putting the cattle dung into that plant, and they are taking the gas from that plant. Pipeline supply is there, and meters are there, and Tata Tea Estate itself is managing that plant. They are able to, in fact, see that how much consumption is done at the per household level. And since earlier they were providing LPG cylinder to these staff quarters, now they are giving this gas to these households, and they are metering it also. Barter system can definitely work on the community level.
Once again, thank you. I think if there are any questions, Mr. P.B. Singh can.
Thanks.
Once again, I'll request participants to any question for Dr. Tiwari. Okay, no questions from participants. I'm requesting Dhamija ma'am to.
Yes, that you take this program forward now with the support of the ministry.
Yep.
So please do as much as you can for the rural farmers. It will be a big help for them, especially the women. That is my concern. They feel empowered when they get cleaner fuels.
Yeah, sure, ma'am.
Yeah.
Thank you, ma'am. Definitely would like to connect with you on this. I will try to come to your office so that we can discuss it further.
Yes.
You can definitely take it on the ground and how it can be more impactful.
Yes. Yeah.
Okay. Anything else, ma'am? Okay. Okay. Thank you, Dr. Ratnesh Tiwari ji. You explained very well about biotechnology.
Thanks a lot, sir.
And once again, thanks a very good presentation. Thank you, sir. We will keep in touch with you.
Thanks a lot.
Thank you, sir.
Thanks a lot, sir,
Very much,
giving me this opportunity. Thanks a lot giving this such opportunity. Also would like to thank you for this initiative. This is very much needed. Awareness on the ground is very much required. That's why this initiative is definitely going to make mark on the ground.
Yes, yes. And thanks all the participants for invaluable times. Thank you very much.
Thank you, sir. Thanks a lot.
Good day.